Okay, so here's the problems from page 598, and I have worked them out, mostly because I kept forgetting to hit record every time I started doing this video. So I'm going to just kind of talk you through these problems, and then if there's anything in particular I feel like I need to point out to you, then I'll point that out along the way. But I am trying to get this done before 7th period gets here. So on the first 3 problems, you can see here, all of them just ask you to find the GCF, and that's it. So you are just strictly looking for the GCF between these 2 terms here and identifying the GCF. And so here on number 2, I actually went through the steps of how you take 2y to the 3rd power and you write that out as each individual prime factor. Same thing with negative 12y, I wrote that out. And then what I've circled is what they have in common. So they both have a 2 in common, so that's part of the GCF, and they both had one of those y's in common, so that's part of the GCF. So overall the GCF is 2 times y. Did the same thing on number 3, wrote that out for 15n to the 5th, and here this is 9n to the 4th. And I looked to see they both have a 3 in common, so that's part of the GCF, and then they had 4 of these in common. So n times n times n times n. So your overall GCF for that one would be 3n to the 4th. Now the rest of these you're factoring. So on all of the rest of these, what I would suggest that you do is keep your sheet handy that goes through the steps. The very first question that you will be asked is, or that you should ask yourself is there a GCF? So on every single one of these problems, you are identifying to see, first of all, is there a GCF? And if there is, you take it out. Once you have the GCF out, which you can see here on each one of these problems, I took a GCF out. Then you look at what's left over and you ask yourself, okay, do I have 2 terms? Do I have 3 terms? Do I have 4 terms? And that's where you get into the rest of the factoring. But if you notice here, I do have 2 terms on each one of these, but they don't meet the qualification of being a difference of 2 squares. These are not perfect squares. These are not perfect squares. These are not perfect squares. So they would both have to be perfect squares, and it would have to be difference on each one of them. Have to be a difference of 2 perfect squares. And they're not, so this is as far on 6, 7, and 8. These are as far as you can go. Number 9 was already separated for you in the regrouping, so you just had to take this and put it together in one parentheses, and then take what was repeated and put it in the second parentheses. So there it is factored, and if you could do anything else, if this happened to be a difference of 2 squares, then you would do that. Okay, so 10 and 11, I'm going to go ahead and talk through the duck call. Okay, so on 10 and 11, these are both regrouping, and I know that they're regrouping. First of all, I would ask myself the GCF question. And I would think, oh, 5 maybe works, but then I would look at the 4 and say, nope, I can't take 5 out of 4. And then think, oh, they're all even numbers, but no, 25 is not an even number. So I'm down to looking at regrouping because there was no GCF. So then I go to regroup. Now, what I would advise that you do is take this and write it in standard form, which is what I did next. Once it's in standard form, I look at the first 2 terms and look for a GCF, which I found 5x squared. And then I'll look at the second 2 terms and find a GCF, which I found 2. Once I take out the GCF, then I can see what's left. And in both of them, when I take that out, I'm left with the 2x minus 5, which then allows me to regroup. So that's the final answer on number 10. Same process on number 11. Standard form, look for a GCF, look for a GCF, and then I'm left with that y minus 1 in both of those parentheses, which then takes me to this answer. Now, if you happen to rewrite yours another way, for instance, you wrote yours in this fashion, y minus 1 times 4y squared plus 3. That would be fine also. Both of these mean the same thing. Number 12. You look first of all for a GCF, which we take out, and then you start asking yourself, okay, there's a trinomial. Surely this factors into 2 binomials. It doesn't. This is as far as you can take this problem. So this is completely factored. There's nothing more you can do. All right, number 13. You have trinomial, so you ask yourself again, do you have a GCF? But if you look at this, the leading coefficient's 1, so there's not going to be a GCF that works all the way across. So then I start factoring, and I think of factors of x squared. Really, I'm looking at factors of 1, the coefficient for this, and factors of 5. And this one's fairly simple, so I see the answer is x plus 1 times x plus 5. And I always check myself by doing the outer and the inner term just to make sure I get the 6x, which is what I wanted right there in the middle. I have a minus and a minus sign here. I see my leading coefficient still 1. That makes it nice and easy. And I start thinking of factors of negative 21. So negative means these signs have to be different. And I'm looking for something that's going to give me that negative 4. And the only thing I see that seems to work is this one right here. So I plug it in. And then I check myself with the outer and the inner to make sure I get that middle term, that negative 4x. Same thing again, my leading coefficient's 1, makes it nice and easy. And this time though, notice I have two negatives, two negatives. The reason for that is, two negatives when I multiply still give me that positive, but when I add them together, I want that negative 8. So this is the one I go with, x minus 3, x minus 5. Number 16. I have a leading coefficient other than 1. So now's where it's going to be important to really ask myself about the GCF. And 2 can't come out of these, so I'd leave it as it is. And then I start playing around with factors of 2 and factors of 7 to get me 9. I don't want 2 to be multiplied times 7 because that'll give me 14x. So that's going to be too big. But if I can figure out a way to put these numbers in here so that I get the 2x, which I did, and then my 7x. So when I add those together, I get 9x, which is my middle term. And again, you have to play around with the numbers until you get them in the right order. All right, number 17. Again, I have that 2x squared. So GCF, there's not one. Looks like I almost had one, but 2 does not go into 9 evenly. And then I listed out my factors here of negative 18. And you can see I have quite a few I can play around with. So I did this in pencil, and that way I knew 2x was going to be 2x and 1x. So I left that in pen, but I put these in pencil so I could erase. After I tested each one, I knew that one didn't work. So then I could go to the next one that I wanted to test to try and get the one that works. And this is the end and final answer. All right, this one has a leading coefficient not just of a number other than 1, but negative 3. So when I take this out, I'm not going to take out just a GCF of a positive number. I'm going to get rid of this negative part so that it changes the sign of everything. It just makes it a little easier when we're factoring. So there's no other number other than negative 1 that works. So I'm going to use negative 1, take that out, and it just changed the signs. Now I look at this, cover that up for just a second. I'm going to look at the rest of that problem to see what can I do to factor it. You can see my list of factors that I tested, and I just play around with it until I get to that positive 2x that I want in the middle. And you can see what got me to that point. When I have this here for my 6x and my minus 4x, that gives me that 2x. Now when I go to circle my answer, remember, negative 1 is part of the answer. It's one of the factors. So that is part of the answer not to be excluded. Negative 1 times 3x minus 4 times 1x plus 2. All right, 29. First question, GCF. Yes, there is a GCF. Second question, can I factor this trinomial? Is it a perfect square trinomial? It's not, but I can factor it, and so it factors right here. Second one, number 30. Is there a GCF? Absolutely. GCF right here, 3x to the third. Then ask yourself if you have a binomial. Is it a difference of two squares? It's a difference of two perfect squares, so it factors right here. And there's your final answer. All right. Number 31, I want you to see the mistake I made because I'm sure you made it too, or some of you did. I forgot to ask myself about the GCF. And I just started the problem off. Now, does that mean I'd get a wrong answer? No, not necessarily, but sometimes it helps to follow those steps for a reason. So I started over again and I said, okay, what is the GCF? And took out 4.
Attention all 8B algebra
and you can see what we have here.
You need to see Ms. Nelson today for the test.
So I took a GCF out of these.
The test will be Tuesday.
I took a GCF
Again, this is for all
out of this. I'm
algebra
left with,
students. You need to see Mrs. Nelson today for the test review questions.
This needs to be a plus.
Is Tuesday.
So now I'm left with the same thing, and then this goes down. The 2x squared minus 5 comes down here, and the x plus 8 comes down here, right here. Now I'm sorry about that distraction. Hopefully you can see the steps, though, to get through this. Alright, 32 is a little tricky, only because of the letters. When you get to this point, these variables, I'm sorry, not letters, variables. When you take out your GCF, and then you look over here and you have a perfect square. I have the question there because you're supposed to ask yourself, is this a perfect square? It is. It's a difference of two perfect squares. One is a perfect square, and c to the 6d squared is a perfect square. So it breaks down to this right here. And there's your final answer. Number 33, GCF, took that out. Then we have a perfect square trinomial, and it breaks down to this. but this repeats twice, so I take it back to here and put it to an exponent of 2. 34 was tricky. All right, so you take out the GCF first and you're left with this. This is a difference of 2 squares. So now it breaks down to this. This is a difference of 2 squares, so it breaks down to this, not excluding the m4 plus 1. This one is a difference of 2 squares, so then it breaks down to this. And that comes down here, and that comes down here. So that was the final answer on that one. Pretty tricky. Okay, if I can, I am going to get the worksheet complete and add it onto my webpage, but we'll see. All right, thanks. Bye. Good luck.